Hey everybody, welcome back to the channel. My name is John, and today I have a little bit of a different video for you. We're not going to do a build video. We're going to do some slicer stuff. I spend a lot of time kind of lurking in the 3D printing subreddits, trying to pick up little tips and tricks that maybe things that I don't know. And I see a common theme with a lot of questions about slicers, basically. Which slicer to use, how to do this in a slicer, how to do that in a slicer. So this is kind of my take on a slicer video. Kind of oriented towards beginners. If you're a power user, this probably isn't the video for you, but maybe there is some stuff in here that you're not doing or that you didn't know about before. So we're gonna hop right into it. All right, so the slicer that I'm using for this is Orca slicer. I've used several other slicers. I used the Creality slicer when I first got my Ender 3 Pro. I used Cura slicer after that. I think I went to Prusa slicer. And then I got a Bamboo Lab P1P, so I went to Bamboo Slicer. And the one that I have settled on finally kind of after that evolution is Orca Slicer, which is a branch of Bamboo, which is a branch of Prusa. So if you're using Prusa or Bamboo, Orca is going to be very similar to those. The reason that I like Orca is because it has basically all of the features of those other slicers, but it allows you to very, very easily swap between profiles for multiple printers. So if you have more than one printer, especially more than one printer from a different brand, you can very easily add those other printers to Orca Slicer and swap between them. So you'll see here I have my Ender 3 Pro, which does still get used a little bit here and there. And I can just click that button and it swaps me to the Ender 3 Pro build plate. And now any G code that is rendered if I slice a model will be sliced for an Ender 3 Pro and not the P1P. And you can do that with several printers, so you can have 6 printers from 6 different brands and likely support them all through Orca Slicer. Another awesome feature is that it also supports the web interface that a lot of printers these days have it coming out with. So if you have like a Bamboo Lab, you can still send prints over the web through Orca Slicer just like on Bamboo Lab. But if you have like say one of the newer Enders or Creality printers like a K1 perhaps that also supports that, instead of having to bring up Creality or Cura for that to send over the web and then using Orca or Bamboo to send that to your Bamboo, so you can do it all from Orca Slicer. You don't have to use 2 slicers for your different printers anymore. That's why I recommend Orca. Okay, kind of a short story long there on that one. All right, the first things that we're going to look at is the quality tab here. I like to click this advanced button here. Otherwise, you just don't have very much going on with what you're able to do. So I recommend jumping right into the advanced tab. Most of the stuff you're never going to change, but it is nice to see how certain parameters and things are affected. So this is layer height here. This determines the thickness of each layer that your machine's going to put down. The standard for most models is like a 0.2 millimeter. They do go very small, and if you're using a 0.4 nozzle, anything lower than like a 0.12, you're kind of getting into a space where you're not getting much out of it. Or you can go high if you're just kind of prototyping, drafting some stuff. You go into a higher. The thicker the layer, the faster it prints. The smaller the layer, the more detail you get. But it also adds a lot to your print time. Align with first layer. Most of this stuff you'll never have to mess with. Okay, I just ignore that honestly, and I use the default profiles for 95% of my printing. The next aspect is called seam position, and seams you don't really mess with very often. I threw in this is a Sylvie Crown from the Loki TV series, but you can see these little white lines here. That is essentially the seam. Now the slicer will automatically try to hide the seam generally into some edges so that you don't see it. But what the seam is essentially where the printer starts and ends each layer, right? So if you're printing something that's just like a dome, well, sometimes the seam will just end up in the middle of the print and it'll just look like this little line that goes across your print. I see a lot of posts about that on Reddit too. Like, what is this line? How do I get rid of it? That's just the seam. That's where your printer head starts and stops that layer. If you don't want it to be aligned like this, you can just switch it to random, right? And that way your printer is going to automatically start and stop the seam in a different place. So you can see all these little white dots we have now. It's starting each layer in a random location. So you're not going to get that line. Not something you need to deal with most prints, but it is nice to know that you can move that seam if you get a print and you don't want to sand that down. The precision section here, I've never had to touch before, so we're going to kind of pass that. The ironing tab is nice to know about if you are printing things with a lot of flat surface. So basically what ironing is that you see these little layer lines here on the final print, right? If you've had something with a flat surface and it's come out with these like diagonal lines, or it could be a different pattern depending on your settings, ironing tries to take those away from there and make it into a very, very smooth flat surface. And there's a few options to do this. If you're printing like a cube, I just added this cube in here to do that. You're going to want to change to like topmost surface. So the very top will be ironed. If you have a more advanced or more like organic model, maybe all top surfaces, if there's like a lot of branches and stuff coming off of it. Generally the ironing flow rate is going to need to be a little bit higher. I usually do this like at 23 to 30%, kind of depending on the model. And it's really just a game of trial and error, because it's going to be a little bit different per model and per filament that you use as well. But if I reslice that, adding ironing, you can see that there's a different color here that is corresponding to the ironing up here. So it tells you how long it's going to take to iron this model on top, and it should give you a little bit smoother of a surface. But again, that's a very trial and error thing. If you want to dial it in for a filament, I recommend you just add a bunch of like little cubes. And you can do that by right clicking the build plate, adding primitive, and put cube, or you can add discs as well. Discs are actually probably even easier. Add discs like that, and then just print that with ironing settings, and work until you get the smoothest setting that you want. So the next thing, you've got a wall generator. You've got Arachne and Classic. I generally leave it on Classic. Arachne will sometimes save you a little bit of print time and a little bit of filament. I haven't noticed it to be a huge difference, so I generally stick with Classic. Some people only use Arachne. Print 2 of the same models with 1 of each and see if you can notice a big difference, and see if there's a massive time savings there for you. Walls and surfaces, I don't change this very often. This is very specific for certain prints, whether you want wall print order, inner or outer first. I generally always go inner outer. Again, I'm printing mostly like cosplay, like masks and props and stuff like that. A lot of my prints are also being finished with sanding and painting. So this is something that I generally leave alone. Bridging, I have never touched. Overhangs, I have never touched. All right, strength settings. A big misconception in 3D printing is that the strength comes from the infill. The strength does not come from the infill. If you want to make a print more tolerant, more durable, less prone to breaking, that's going to come from walls. Okay, it's not going to be coming from your infill. Generally, infill adds weight, and it can add, if you're selling, it can add a little bit of like a quality feel to it because you're adding more weight to the print. But keep in mind, a higher percentage of infill is also going to lead to a higher filament usage and a higher print time. Just to show you that here, let's add a primitive. We'll add a cylinder, and we're just going to make this guy like kind of tall, right? And then we'll do I'm gyroid gang for life. That's the one I like. A lot of people on the Reddit will also talk about like they hear a dragging sound, especially if they're new to printing. They hear a dragging sound. A lot of times they're using a grid infill, and I'll show you what that looks like here, and it's this. And so the reason you get that dragging sound when doing a grid infill is because your nozzle literally scrapes across all these little layers, and so it gets that little sound. Grid infill, not a big fan, have never really used it personally. Gyroid gang for life. The new one, what is it, crosshatch, is supposed to be pretty good too, but I just stick with gyroid because it makes printer go burr. But gyroid is very, very stable. It gives a little bit of rigidity to the model. It doesn't take a lot of extra print time. And in terms of like compression force and things like that, I think somebody did a test that gyroid was one of the most consistent ones. So if you are printing a part that needs to undergo compression or pulling or torsion forces, gyroid is generally kind of your best all-around pick for all those. But when we come down to like infill density, it doesn't matter too much, especially for the type of stuff that I'm printing, right? We can drop that down. Most of my helmets I print at between 5 and 10% infill. And you can see there's a lot of kind of empty space in there, and you'd think, wow, this part's going to be super weak. And with just 2 walls, it's probably not going to be super durable. You can see the walls here. Orange is one wall, the yellow is the inner wall, right? If you want to make your part more durable and longer lasting, it will add some print time, right? We're at 9.6 grams here and an hour and 2 minutes to print this cylinder as is. But if we crank that up to 4 walls and then we reslice it, now print time is not too bad. Didn't change really much, but we have a little bit more filament usage. So we added, 6 grams of filament basically, right? On bigger models, obviously that scale's bigger, but this print is now going to be very, very rigid because of these walls. Okay. Adding walls will make your print stronger than adding infill. Unless you're going like 100% infill, just add walls. Okay. If you don't care about it feeling light. Another thing to note while we are in here, I guess, with the slicer is that Printing a cylinder straight up and down that needs to be stable or is going to be like the long end of a pole or a rod or something is generally a bad idea. Because of these layer lines and the way that they are positioned like this, they are going to be their weakest when holding that out long ways, right? So that's going to want to break along these layer lines, right? And that's just the weakest, literally the weakest way to print this. So if you did have a cylinder or something you wanted to print, and this is a slicing feature, cutting feature that is in most of these slicers as well, you bring this up and you're going to want to cut these in half. So perform cut, and then now you'll cut them in half like that, and then you can click on this lay on face button and click on that, and now you want to print them like this, and then you'll just glue them back together. Because now the layer lines, if we reslice it, it's not going to look quite as pretty, but the layer lines are going to be going longitudinal, right? Which means if you try to bend this in half like breaking a stick, it's going to be significantly harder to do. So if you ever have to print something long and you can't like reinforce it with a wooden rod or a metal rod or a screw or something, slice it in half, print it like this, glue it back together. Trust me, it will be so much stronger, and you don't even have to do 4 walls on this. I would still do like 3 or 4 if it's a big long like cosplay prop, but you won't necessarily have to. This will be significantly stronger already. Okay, so back into the strength tab. That is pretty much how infill works. Top surface pattern, bottom surface pattern, I always leave those at monotonic or monotonic line. You can change those to whatever you want. It just changes the look of whatever it is you're printing on that very, very topmost layer. So kind of like this, right? So you've got, I changed it to a Hilbert curve over here, and now we have these like goofy little maze looking things on top. Most of the time, monotonic line is going to be what you're used to seeing and what most people are doing. Advanced settings in strength, I have never touched. Over to speed. I generally just use the profiles that Bamboo or Orca uses for their system presets for their types of filament. I pretty much I've really never used Bamboo filament itself. I only got the roll that came with the P1P that I bought. I generally always use like Sunlu, and there's a handful of other ones that I've used as well. I've never used really a bad filament. I've heard good things about, Sunlu, eSun, insert filament here. There's a ton of different options out there, and the generic profiles have always worked well for me across multiple different brands. Speed settings I've never really had to touch. If you're printing something that's really, really small or has a lot of like detail, or is like a print in place model where it has moving parts that are printed as, that are put together as it's printed, you might slow down the first layer a little bit just to make sure that those come out really, really crisp. But other than that, I have never touched the speed tab at all. Support settings. So support settings are pretty important depending on the model that you're printing. Let me pull one up here. So I've got the Deadpool helmet here. This one is by Yosh Studios for the newest movie. And the support settings can be a little tricky, right? Because we've got a few different things in here. You've got normal, tree, normal manual, and tree manual. If you were going to paint supports on, spend the time to do that, you absolutely can. The way that you do that is you select your model. You're going to go up to support painting here, and then you're going to want to add supports to the spots. The spots highlighted in red are where the model is being detected as having overhangs that might need support, and you can highlight those here at the angle that you want. So if you increase this, you see more stuff gets highlighted. You should support it more, generally like a 25 to 30 degree angle. Your printer, especially a Bamboo Lab, is going to be able to print without needing supports. But it does give you a nice little kind of area of like, maybe add some supports here, right? You can also block out supports like on domes, like on helmets like this. You do not need supports on the inside. You can raise the pin size there, and then it would be a right click and paint to get rid of that. If you wanted supports, it would be a left click and paint. And now you've got those green supports in there. All right, so that's pretty easy support painting. Again, very model dependent. The only time I usually use this is if I have a print that is failing consistently at the same spot, or if I'm printing a helmet that has a dome-like structure and I need to erase all the supports on the middle so I don't have this giant tree cluster of wasted filament. Back to this, the actual support settings themselves. What is the difference between like tree slim and tree strong and tree hybrid or whatever, or default, right? The biggest difference that I found is that tree slim, it uses a little bit less filament. They are obviously slimmer. However, it is a great workaround for some prints. So if I set this to tree default and then we slice this helmet, you can see that I'm getting a G-code path error down here. This isn't going to work, right? Because it is generating supports that are going over the build plate, and that simply will not work. But I can't orient this model and keep it the same size so that it fits a 24-inch head and fit it on this build plate with any other way, really. So I have to figure out a way to get these supports to not do that. The easiest ways that I have found is to just change those to slim supports. This pop-up is going to ask you, we recommend using 0 interface layers, 0 top distance, and 2 walls. I always say no to this. The reason being, 0 top distance and 0 interface layers, it basically wants to change your top Z distance here, which is the distance between the top support and the area of the model that it's supporting, to 0. So it's essentially going to try to fuse your support to your model, right? Which is going to make them really, really difficult to remove, and you're probably going to have to file a lot of them down. So I always click no on that. I want my Z distance to be at least 0.2. Some people always even go 0.3, 0.4. Okay, this just makes the bigger number here, the easier it is to remove supports, but also the more potential kind of dropping you'll have on those layers that are resting up against the supports. Okay, so if we went to slim supports here, you can see that now we no longer have that G-code error, because the slim supports, for whatever reason, don't go past the build plate, and they don't render past the build plate. They just make them flat right along the edge there. So now I can print this mask totally fine using these supports. And if you're looking over here, we probably saved a little bit of filament and maybe even a little bit of print time. Nothing substantial, but it makes this printable. And that's the easiest way that I have found to do that. Okay. If you're going to normal supports, same type of thing. You can go auto, or you can paint. There's grid and snug. Snug is going to use less support structure. It's going to be a little bit more filament friendly, and supports really well. I generally use snug when I'm going with normal supports. I don't use normal supports very often, but there are some models where normal supports just make more sense than tree supports. So I highly recommend that you play with those and figure out, maybe even slice your model using tree supports. Write down how much filament and how much time it's going to take, and then slice the model using normal supports and see which one is going to be more efficient for your use case. They both support really well. They're both fairly easy to remove, so it just kind of depends on what you're looking for. So here you can see the mask has been sliced with normal supports, and if you were looking over here at the estimations and stuff, you can see that we have added roughly 3 hours to our total print time, and we are using a lot more filament as well. So normal supports on this type of structure are not necessarily the move, right? You can see that they don't just go exactly where they're painted, because they have to build up in more straight grid-like lines. Okay. Going to snug, you could save a little bit of material on this. Again, you're gonna have to play with supports a little bit, but that's the major differences between the tree or organic supports and the normal supports. These ones do not reach those hard to get spaces. And sometimes they use a lot less filament, sometimes they use more filament. It just depends on what your model looks like. And another section, or another thing over here in the support, on build plate only, I pretty much always use this option with tree supports, because otherwise it will start tree supports like in the model. Like if you had a model that had like 2 holes for eyes, and it was like a mask that was oriented straight up, it would just build support like in the eye, right? Which is fine for normal supports, because you just take some pliers and rip them out, and it's usually pretty easy. But on tree supports, I find that it's a little tougher to do that. And if you use on build plate only, it will literally just build the tree support up and then into the eye itself without having to build it, like rip it off the model. So instead of supporting basically from like this ledge to this ledge, it would support from here all the way up to there, right? So a little more filament, I guess, at times, but it makes the removal very, very easy. Raft layers, rafts generally aren't used very much anymore. They were originally used a lot if you had a printer that you weren't sure about the bed leveling on it. The raft is basically a layer of filament that the printer will put down to kind of raise up the print. It also helps a little bit with adhesion. I haven't used rafts on my P1P ever. I did use them a little bit on my Ender 3 Pro, but again, it's generally just for beds that you're not super confident in their being level. Filament for supports. This is if you have an AMS system, you can change the filament to have, like if you're doing a PLA print, you can do PETG supports so that they just fall off because they don't fuse. They're different material compounds, right? Not something I use. I don't use an AMS. I don't have an AMS. Under the advanced tab in support, you've got your top Z distance, which we kind of touched on a little bit. That is just the distance between the top of the support and the bottom of the model that it is supporting. A bigger distance there makes them easier to remove. But if you get too large in that distance, then the filament will start drooping down because it's not actually touching the support. So generally a 0.2 to 0.3 for most print profiles is going to be good enough. Anything else in here, I don't touch ever. I don't touch anything down here. If you're having some issues with your tree supports not being strong enough, you can change the tree support branch diameter, which will make them a little bit thicker at the base. Under the others tab, you've got things like skirts, which I haven't used since my Ender 3 Pro either, so I kind of skip over that. Brim, sometimes you'll still get brims that wants to pop up. If you don't know what a brim is, it's basically when your printer puts these little, almost what you would call a skirt, right? It puts this little brim alongside prints. It just helps with bed adhesion. So prints that have really small areas that are contacting the bed, it attaches a little bit to the print and then to the bed and helps with adhesion so it doesn't fall over. A brim object gap here, that is essentially the Z distance of your brim, right? So how the Z distance was the support to model interface distance. This is the distance where the brim meets the actual model here. Generally a 0.1 to 0.3 on this works out really well too. Brims generally come off really easily, and if not, you can just cut them off or rip them off, right? They don't usually leave any damage to the model or anything. Generally, I'll leave this on auto. If it wants to make a little brim, usually not a big deal. Sometimes if you're doing a lot of print in place models like Flexi Lizards, Flexi Rexies, things like that, you're going to want to turn brim off because it's going to be a nightmare for the removing of the brim on those type of models that have a lot of really small spots that are touching the build plate. You just got to make sure if you're doing a lot of those models that your build plate is very clean, or that you're maybe even using glue or hairspray depending on the build plate type you have. Prime tower, that is an AMS thing. I don't have an AMS, so I don't know much about that. Flush objects in the infill, this is ways to cut down on your AMS poop on the waist. If you're doing a lot of layer switches or color switches, you can kind of mess with that and customize that. That is very subjective to what you're doing and what you're printing. Again, no AMS here, so I don't mess with that at all. I've never even looked at special mode. I don't modify the G code myself. And that is pretty much it for the actual settings. I know that was a lot to go through right there on the advanced tab. But hopefully you guys have a little bit better understanding of at least the defaults and kind of what you need to mess with when you need to mess with them. Now we'll go on to some tips and tricks, I guess, in the slicer, stuff that people don't generally know about, that can be helpful. So we're starting with a blank build plate. Say you had a model, you had a figurine, and you wanted to make it a little more stable, right? You wanted to add like a base plate to it, okay? You can right click the plate, go to add primitive, and then add a disc. I'm going to add a cylinder here too. This will be our quote unquote action figure that we're trying to print, right? And then, oh no, my cylinder went over my disc. Now I can't get my disc anymore. You can click over here on objects, and that shows you everything that is on your build plate. So you can select your disc, and then you can go to scaling, and then you can make your disc bigger. Now, if I just left these like that and printed it, these two parts are going to be fused, right? The slicer is going to automatically put them together, and they're going to print that as one object. So if you had a model that needed a base, so it didn't fall over, then you can add a little disc base to one or both legs or wherever you need it to add very, very easily in the slicer itself. You don't have to know any 3D modeling to do that. If you didn't want that, the cylinder, you can delete that. If you wanted the disc to be a little thicker, just select it and you go to scale, and you're going to want to do non-uniform scale here. So make sure you click that, and then you can just drag this up, or you can type into the Z axis here and make that really as thick as you want. And then you can re-click uniform scale, and then you can size it up kind of however you want to do it. So lots of options there. I've used this for printing like big headphone holders and things like that. It's a really nice feature to have if you just need a little more stability in your prints. Another cool feature about these slicers is that instead of just adding shapes to things, you can also take away shapes to things. The way that you do this is you right click your model and you would add negative part. So you can see here these two little like these ghost cylinder type things that I've added here. And this basically tells the slicer to not fill in this area. So it's just going to make these in the little circles. So this was just a test I was using. This is obviously just like a Halloween candy skull bowl. But say you wanted to make it into a hanging pot planter, but you didn't want to drill holes in it. You just wanted it to print with holes. Well, you can go through and you can do this with the adding a negative part. And so we add the cylinder. and then we size it length and diameter to whatever it is we need it to be. And then when we actually slice the model, you can see that those areas are left out. And now we have these nice little holes here you could attach a rope to, right? So a very, very easy way to modify models inside the actual slicer. Again, you don't have to know anything about 3D modeling to be able to do that. It's just embedded in the slicer, and not very many people use this. Another way that you can remove supports from some places, if you didn't feel like doing the painting here, is you can add what's called a support blocker. Again, you'll right click your model, you'll go to add support blocker. We don't want that dome, so we'll add a cylinder. And we get this little red cylinder here. You're going to go to scale, and we're going to bring that bad boy up. We're going to widen it up a little bit, and we are going to position it right there. Now, no supports are going to be generated wherever that red is. So make that as big or as little as you need it to be, and you're not going to have any supports on that area anymore. So just an alternative to painting, not necessarily better, sometimes a little easier, sometimes can be a little quicker if you have a complex object. But that just blocks all supports. Very, very simple. So looking at another variation of that Deadpool model before, this one doesn't have any texture on it. Textural models goes a long way to hide layer lines, but if you're printing something really smooth, those layer lines are going to show up, especially if you have a dome. As you can see here, we get this kind of ringing, this bullseye thing. This is called stair stepping, and each one of those layers is going to be painfully visible when this comes off the build plate. And that's why a lot of people for these type of things will go ahead and sand those down to make sure those are gone. If you don't want to do any sanding, the best that you can get with this is a little bit of just layer line refinement. And the way that you do that is called variable layer height. It's this button up here. You click it, and now it shows you where the ringing is. And so you can see kind of what's going on here. I generally leave all these the same. And over here, you can see as I move my mouse up and down, it tells me kind of where I'm highlighting. So you can click and you can go up and down that way, and you see how this turns over to green, right? And you're kind of painting on here. And so basically, this is telling you over on the side how tall those layers are going to be as you come up to that kind of bullseye stair stepping area. So it's going to transition from a 0.2 layer height, and then it's going to go down to a 0.96, 0.92, 0.17, 0.159, and so on and so forth, all the way down until it eventually gets down to the smallest that it can print, which is like a 0.08 layer height. So it helps reduce that stair stepping. It is not going to take it away completely, but it will make it less visible to the eye. The only problem with doing this on a model that you don't plan to paint is that you tend to get striations in the model that are visible to the naked eye. Generally, I would do this if you're trying to save a little bit of post-processing work, or you're, selling something on Etsy or whatever, and you're not going to post-process it. Okay, so a few other things on here. Basics, if you need to add another plate to your project, you can just simply click the add plate button. If you want to delete a plate, you can remove a plate. If you want to add, this is to add another file, it'll open up your file browser. If you want to auto orient, if you just want to let the computer do its thing and orient the model for itself, you can click that and it'll do its best to orient it in a way that is friendly to printing. If you have a whole bunch of things on a build plate and you want to auto arrange them, then you click the auto arrange button. You can also allow it to rotate different models. It's not going to do much here with just this one. That's fine. The spacing can be a problem with this, especially if it's a bunch of models that have like a bunch of weird supports that are needed. Sometimes it'll put them really close together, and then there won't be enough room for the supports to not clash with the other models. So spacing sometimes helps depending on what you're printing. All that is fairly self-explanatory, I feel. You have your moving. If you're trying to move something really easily, you have your rotation. If you're rotating out here, it's free rotation. If you bring your mouse into the tick marks, it locks you to every like 5 degrees. It auto clicks it, right? Which makes it really nice. Lay on face. This will highlight all the different faces that you can put your prop on. So if you wanted to print it on the eye, okay, you can print it like that. I guess I wouldn't recommend it, but you certainly can. Scale, pretty self-explanatory. You can either drag or you can type in here if you just want to up something by 10%. And then you have seam painting, which is that seam that we talked about earlier, this white line here. On this prop, on this print, this is going to leave a little valley, a little seam where it starts and stops. If you didn't want that, you can just make it random, or you can paint your own seam using the seam painting. I've never had to do seam painting myself. I just let the computer handle that. You can emboss prints. This can get a little tricky if you're trying to put like a specific word on something. It is possible to do it on these curved surfaces. You just have to go to advanced and click on use surface, and then it will kind of automatically bend it to it. And that works mostly well. You can tell that the text is sticking out. If you wanted the text to be inset into the model, kind of like carved out instead of embossed on it, then you have to change this operation down to cut, and that will push the text into the model, so it will print basically around it, as you can see here. How the text is inside the model. Generally, it's small enough you're going to be able to bridge that. You're not going to need to put supports in there or anything, because good luck getting them out. Another cool feature that was recently added, I guess it's probably been in a couple months now, is the measure tool. If you are printing like a cosplay helmet, or you need to know the internal diameter or how long something is, because you need just the measurements, they finally added a measurement tool to Orca Slicer. Very, very easy to use. You just click on one side, and then you get that little blue dot, and then you click on the other side, and it just draws you a line that tells you exactly how long it is from point to point. So it's 100 millimeters basically from that dot to that dot. So that kind of brings me to a little more advanced thing in the slicer that you can do in how to like kind of sizing a helmet. I don't want to get too far into the how to size a helmet. I just want to show you the basic ability of how to get around doing that just in the slicer itself. There's plenty of ways to do it. This is generally how I do it. In Orca Slicer, at least I haven't figured out a way to turn off the snapping to the bed. So anytime that you say you move this up, it's just going to snap back down. I think you can turn that off in like Cura Slicer, but for whatever reason, Orca, you cannot. But there is a way around it. So the way that I do it, you select both objects, and these are just sizing heads. You go to any STL site, Maker World, Printables, Thingiverse, whatever, just type in sizing heads, and these are a free download, okay? A little bit of math involved if you want to find the one that's exactly your head. I'm not going to get into that too much today, but these are super, super helpful. These are basically how I size all my helmets to make sure that they're going to fit when they come off the bed. But anyway, you select the sizing head, and you select the helmet, and then you go to assemble. And now this basically makes them into one object. You can still manipulate them individually if you go into the object section here. So I'm going to move this over. I'll just center that, and now I will click on the helmet itself. And now when I bring up the helmet, it will sit there. Oh no, but they're both gray, right? Like that's kind of annoying. So what you can do is you can add a color, and then you can right click the helmet or whatever model you want, and you go to change filament, and now you've made that yellow. Probably should have made it red because Daredevil, but you know, whatever. And so now you've got a little bit easier way to play around with this. So at 100% sizing, this isn't going to fit my head, right? You can see that it's just too small. It's not working there. So we're going to scale it up a little bit. Now you can do this percentages. So we'll go like 106%, right? And see how that works. And now we can click back on to the Daredevil helmet as well. And we can kind of move it up and down and forward and back. And you can see a little bit, okay, that's a little bit bigger or better fit. We probably need to go up a little bit more. So we'll do like 108%. And we're getting there. We're closer, probably. If I did it like this, I could cut the back and attach it with some elastic cord, and it would fit really, really well. But if I wanted to be able to slide on my head, that's not going to be big enough. So, you know, play with it like that. Just make it so it's not, you know, nothing sticking out through the actual model, right? But, you know, that looks pretty good. I could easily print that, and I could be confident that that is going to fit on my head. That's how I size most of my helmets, using the actual slicer itself. So you don't have to do something like 3D Builder or just measuring using the measurement tool and hoping. You can actually put it on, see kind of what it's going to look like and how it'll fit, and very, very easy to do inside the slicer itself. All right, so that's pretty much the whole Orca Slicer video, guys. I really enjoy using Orca Slicer. Like I said, I've used like 5 or 6 different slicers. I kept coming back to Orca. It has all the features that I want, mostly, and it just has a lot that you can do inside the slicer without having to learn 3D modeling and importing objects from Blender into the slicer and then modifying them. You can do a lot of at least small basic adjustments inside the slicer itself. So I hope that that helps you guys kind of determine how to use a slicer a little better, and some of the features that a lot of these slicers have that kind of go unnoticed or underutilized by a lot of people. So if you have any other questions about the slicer or anything down in the comments, do let me know. Be happy to help you out and answer as much as I can. Other than that, guys, I'll see you guys next time. Happy printing.